Okay, we're going to do an experiment on expansion and contraction. What we're going to do is heat up three substances: a solid, a liquid, and a gas. And we'll see the effect that expansion has, the heat has on the expansion of the material or the substance. For the solid, we're going to use a Bunsen burner as the heat source, and then some ice water as the cooling source. For the liquid and for the air, the gas, we'll use boiling water for the heating. Now, the only spot in our water is blue so that we can see it. The only spot that it can go when it expands is up the tube. So we'll see it rise up the tube, we'll mark the spot, and then we'll cool it down. See what happens. When the air is heated and expands, it will start to expand the balloon. The hot air will rise and pump this balloon up a little bit, just a little bit. So, let's go. We need our gas. Make sure that our Bunsen burner is on safety flame. Gas is off. Light it. And we can see that it's on safety flame because it's easy to see from where we are. So we'll turn it to working flame, and it's much harder to see, but I can hear it. So we're going to heat our solid up. This is a bimetallic strip. One side is brass and the other side is iron. One of them will heat up quicker than the other, which will then force it to curve, cause it to curve. Now we don't want to burn it, we just want to heat it up. And we can see that there has been, let's turn that to safety flame, there has been a fair bend in the metallic strip. So let's go back and cool it down. You can hear it cooling down, and we'll leave it sit in there, and we'll see that it will, in the ice water, and then we've had it, it's cool to touch almost. We'll cool it down. We'll leave it sitting in there, and then we're going to use our water here. We'll boil our water while we're waiting, and we're going to heat both our liquid and the gas, which in this instance is air. And like I said, we'll be able to see the air expanding because this balloon will start to blow up a little bit. We see that this has come back down straight, basically, to what it was. So when it was heated up, it expanded to one side because the different temperatures in the bimetallic strip have heated up at a different rate. The brass heated up at a different rate to the iron, and that caused it to pull over to the side. It would occur. So, has our water boiled? Still waiting for our water to boil. Okay, we've got boiling water. You'll see where the level of that is, and you can see where that is as well. So we'll put a bit of water in here. And see if we can get them to expand. You can see here, now you can see that this water, the level is starting to rise. Can you get that? You can come in close to see if you can see that that is rising. So it's expanding, the particles, the heat, the energy being imparted into that is causing the water to expand and rise up the tube. We'll let it rise a little bit. Let it rise to about there will do us. We'll just mark that. And then we'll then cool this down in some iced water. You can see where our mark, where the level of it was. The level rose to that. So that's going to cool down. While that's cooling down, we can see that the balloon has started to expand, because what's happened is the gas particles have started to react and then expand. They're moving and pushing on each other and expanding, and they're going up out of the conical flask and into the balloon, and you can see that that is also expanded or blown up a little bit compared to what it was. Over here you can see where the level was, where the level rose to, and if we can just get a look at that and see that it's actually coming down, see if you can see that it's moving. Should be able to see some movement on that. It's been cooled down. And we can see that that is actually coming down. And that will eventually, when it's absorbed, given off its heat to the ice and the water, that will go back to its state, to its normal liquid state. Now, of course, if we heated that up enough, that would go from a liquid to a gas. And now we're cooling it back down. And here we can see with our air, the gas, how it's expanded and come up into the balloon and blown it up slightly. Not a lot, but enough we can demonstrate how the gas has expanded up into the balloon. And we will cool this one down, and we should see the balloon come back down. I'll leave this in here for a little while. And we see this, if we move this around, get a bit more ice on it, we should see that level on that water keep going down, and see how this balloon has basically gone back to what it was, having that there. We'll move this around, get it in contact a little more with the ice. And we can see that that is cooling back down, so it's gone back down from here down to there. When we heated our bimetallic strip, we saw our bimetallic strip curve over to one side because the imbalance in the two metals. One metal's brass, the other side's iron, and it's heated up quicker on one side and it's pushed it around like that. When we cooled it back down, it came back to its straight area here. When we heated up the gas, we saw that it expanded the balloon, or blew the balloon up a little bit, and now when we cooled it down, those gases have contracted back down and the balloon has gone back down. Now with our liquid, when we heated our liquid, we saw that the liquid rose when it expanded, and the particles are moving faster. They're going up the tube, and we saw the level that it went to is here, and now that it's come back down, you can see where the water, and it's only coloured blue to show that, so you can see it. So the water has come back down to where we were. So what we've done is heated up three substances, a solid, a liquid and a gas, and then we've cooled them and we've seen how they expand, and then we've cooled them down and we've seen that they've contracted back to their original state. And that's the effect of the heating has had on the expansion and the contraction of those three substances. Your task now is to go through that. You can stop the video and have a look at it again. Go through and record the results. You're obviously going to do it online. Record the results and then answer the discussion questions that are there. Once you've answered those ones again here, answer them and explain. The job of the scientist is to explain why it's happened and how it happened, and then do the conclusion. It's It's always good to do a summary, a re-summary, a short summary, then talk about what was found out, and then discuss the results further in the application that it may have. So that is our prac on expansion and contraction. Thank you.